Previously, under OSPF we learned it's a link state routing protocol. This protocol advertises only the link status, not the routing table. That's a very important point that we should mention when someone discusses about OSPF with us. They don't advertise the routing table. They advertise the link status. Every router advertises the connected link status to every other router, along with the router ID. That is also another point we saw. Every router will have a unique ID, either dynamically picked up by OSPF or given by us. Both the ways it can be. Any one of the way it can be. OSPF will need an ID. Using that ID, the link state advertisements will be sent. For example, if A is sending a link state advertisement to B and D, A will put its router ID and send it to B and D. When B forwards it to C, likewise D forwards to C, C will learn it from both, and C will know that I have got two paths to reach A. This is how the topology discovery happens. After a point of time, there won't be any router in this area which don't know the network in that area. Every network within the area will be discovered dynamically through this link state advertisement. Link state advertisement are collected in a database called LSDB, link state database, on every router. The SPF algorithm, the binary tree algorithm, takes care of picking the best path among many and putting the best path into the routing table. Fine. Now this OSPF has got the true topology table which we discussed in the previous class. They don't advertise the routing table, so it's not the partial topology the neighbor learns. It is the link state advertisement, so every neighbor learns about all other neighbors' link status. All the possible links, paths to reach a destination will be learned, using which the best path will be picked up. That's why, OSPF is well known for accurate path selection and very fast convergence protocol. OSPF is a very fast convergence protocol, the fast convergence protocol, because they got the full picture of the topology. Next, OSPF follows this hierarchy design to solve three problems which we learned in the previous class. The hierarchy design with backbone area and all the non-backbone areas connected via the backbone area, communicates via the backbone area. The reason why we have these areas, these are the three reasons we learned. First, when you got multiple areas, you get one summarization point. Which one is the summarization point? The ABRs are the summarization point. C, D and E are the summarization point. For area 1, C is the summarization point. All the area 1 network will be summarized before sending to area 0. As a result, in area 2 and area 3, the routes of area 1 is not going to consume much of routing table. Minimizes routing table entries. That's the first point. Because C advertises only the summary of all the routes that is seen in the area 1. B is going to take the summary of area 1 network and give to other areas. As a result, the other areas routing table will not be too large. This happens also when route comes from area 2 to area 1 and area 3 to area 2 and vice versa. So, that's one of the benefit. The second one is, if there is a small network in area 1 fails, the flooding about the failure will happen only within that area. It won't go beyond the area. It is good. It is not going and disturbing all other area router. Now you may think in your mind now, if the network goes down in area 1 and flooding happens only within area 1, then what about the area 2, area 3 update? Will area 2, area 3 know about this failure? The network has failed in area 1. Will it be known to area 2 and 3 now? No. It won't be. Why? Because we have done summarization. Only when all the subnet goes down, the update will be going to other area. So because you do summarization, there is no chance for other area to know when a subnet goes down in area 1. See 10.1.1.0/24, 10.2.2. or 1.2.0.24, 10.1.3.0/20. These are all subnets for which you have done summarization 10.0.0.0. When this network goes down, every router in this area will know that this network is gone down, but other areas will not know. Why? Because we have to send only the summary route. Won't this be a problem? No. It will not be a problem. Why? See, if we have areas and we got these routers in different area, F in area 1, H in area 3, it is because the networks inside this area are frequent talkers. The network between areas, they don't frequently talk. That's why we have put them in different area. They don't frequently talk. So there is no need for area 2 to know about one small network going down in area 1. It's not relevant for area 2. Area 2 will say, so what? Why are you telling me? That's not my business. If I need, I'll ask you. That's what area 2 is going to say. If you say this network has gone down, area 2 will say, oh, is it? Fine, no problem. But it's a problem for area 1. That's why you suppress the flooding of detailed routes to other area. For other area, it's not needed. They don't talk much to these area members. So a small network going down, one guy in Silk Board met with an accident. What is the use of telling this in Delhi? Delhi people don't care. They will ask, what is Silk Board? Then you need to say, Silk Board is in Bangalore. Oh, Bangalore. Okay. It's okay. I don't know about Bangalore. It's like that. Advertising one small network going down to other area is equal to talking about an accident that happened in Silk Board, Bangalore. In Jammu and Kashmir or in London.
Sir, I have one question here.
Yes.
Sir, except for failure part, when let's say in area 1 we have 10.10, 10.20, and area 2 is 10.30, 10.40 network. Now we are doing summarization CDE. Now from backbone area, if how they will get to know, because we are advertising 10.00/8 C and D.
No, you should not do like that. First of all, say clearly why C and T, all the stuff you say. Let everyone understand. Make it clear. Classful summarization, classless summarization. Yeah. Now, you see, you will not be advertising like that. So that is a design problem. What you speak is a design problem. It's not properly designed. You should not mix like that subnets. Put all that begins with 10, 10 dot in one area. And in area 2, 10.2.x.24. Area 3, 10.3. Do like that so that when you do summarization, you summarize 10.1.00/16. 10.2. This is proper design. If you do like this, then there is no problem.
Okay.
You don't need to summarize to a class full. Why you need to summarize to class full boundaries? Not necessary.
Okay.
Right. So we learned these things in the previous class, that areas in OSPF helps us to scale large. Scalability. Because you got many areas, I'm able to summarize the networks of area 1 before sending to other areas. Area 2 before sending to other area. That reduces the size of the routing table. When you have reduced routing table, it will be faster for a router to decide on a path. Fast route selection. When you have only 2-3 checklists, you can easily make a decision. If you have pages after pages of checklist to decide on one thing, then it takes time. Yeah. So minimizing the routing table, it is possible because of summarization. Summarization is possible because of ABR. ABR is possible because of multiple areas. So not only summarization, not only the minimized routing table, even the localizing the impact. When a network goes down in area 1, if everyone in the area 1 knows, that is enough. That may not be that relevant message to be shared to other area members. For them it is not needed. They don't frequently talk to this particular network that has gone down. So it's not necessary. So within an area, you can expect identical links to database. Throughout the area, don't expect identical topology. I think it was mentioned here. Here. Topology table contains all the routes that are attached in the area. Identical database are within an area. Within an area, you will have identical database. Why? Because the detailed flooding is within the boundaries, within the area. So all the area members will have identical database. Everyone is updated immediately within the area. That also localize the topology change impact. Not other areas are going to be impacted. So this is the reason why we need this hierarchy design. And we also learned some terminologies. ABR is the router that will have two database. Don't forget. ABR will have two database. One for the area 0, the other for the area to which it belongs to. If E belongs to area 3, then you will have LSDB for area 3 as well as area 0. We call such routers as ABR router, area border router. See, without this area border router, it is not possible for you to take route updates from one area and give it to other area. It is only via the backbone area, area 0. That's why area 0 is called as backbone area. Router B and A are backbone routers because they are within the area 0. See, all the links of B router, they are all completely in area 0. Wait, come on. This link, you see, this link, they're not in area 1, 2, 3. They are in area 0. This is area 0. This is area 0. This is area 0. So this is obviously it's not a ABR. It is not a ABR. It is backbone. Likewise, this is internal to area 1. Only these are backbones. Now, I want to add something to this picture. Let us say we got one router connected to, please focus, another area 0. Or let's say area 5. Or let's say area 2. This is another area 2. Which has got another area 0, another area 1, area 3. We call this as another autonomous system, another OSPF. Here also I am running OSPF, here also I am running OSPF. Can we say one autonomous system? No. This is another autonomous system. So what we have to do is, this link, this link should be in area 2. This is in area 1. This is area 2 of this autonomous system, red autonomous system. So we have to redistribute from this area 2 to this autonomous system area 1. So you need to run 2 OSPF. How many OSPF? 2 OSPF. How you differentiate one OSPF from the other OSPF? With the help of process ID. So you will be configuring here router OSPF 1 and you will point towards this network. And then you will say another router OSPF 2 and you will point towards this network on this link, red link. So there will be 2 OSPF running in this router. Protocol may be OSPF, but it is 2 separate instances. It is equal to 2 different protocols. So between the protocols, unless you redistribute the routes won't go. We need to redistribute the routes from this OSPF to this OSPF. Means OSPF 2 to OSPF 1, OSPF 1 to OSPF 2. Only then someone from here alpha can ping someone here in beta. If someone from alpha needs to ping someone in beta, we need to merge these two by redistributing from this. This is what the router where we do redistribution from this OSPF to that OSPF. If you don't like OSPF, you may have EIGRP here. Then now you need to redistribute from EIGRP to the OSPF. And we call this router where you have redistribution done between this protocol as Autonomous System Border Router, ASBR. The router where we redistribute routes from another protocol. It may be another OSPF or EIGRP or RIP or static or connected. whatever it may be, BGP or ISS. When you take the routes from that OSPF and that protocol and give it to this protocol, this OSPF here in this autonomous system, we call that router where we do redistribution.
So in that case, router
as
A
autonomous system border router.
ASBR.
Wait a minute, please. Wait a minute, Arindra. So F is the place where we were redistributing. See the word redistribute, no? Distribute it once again. It was in one protocol, now you are giving to another protocol. We call it as ASBR router. Yes, Arindra.
So if F router connected to the G or X, both way we are doing the redistribution, so both we call it as a ASBR.
What? F is connected to G?
Some other router, other area 2. So we are doing redistribution.
You cannot connect like this. No, it's not possible.
No. Other area means, as you said, that area.
Okay. Here is another area.
Autonomous system.
Area 2. And there is area 0 here. This is area 2 for our reference, but according to F, this is some other protocol. This is another OSPF, OSPF 2, area 2. This is OSPF 1, area 1. This link is OSPF 1. This link is OSPF 2, autonomous system. OSPF 2 process ID is what differentiates here. OSPF 2, area 2. We call this router where this 2 protocol is going to redistribute. Unless you do redistribution, it cannot be an ASBR. ASBR is autonomous system border router.
Yes.
But did I answer your question? I did not first of all understand your question. Repeat the question if I didn't answer your question.
No, the reason is I was asking, sir, you said while we are doing redistribution, if we do redistribution in both sides, let's say F router, which is connecting to other process ID, and their other router is connected, so let's OSPF, and we are doing redistribution on other side also to get the updates.
Yeah. Of both sides you need to redistribute. For both it will be an ASBR, correct. For both F will act as a ASBR. For the below autonomous system, F is an ASBR. For this autonomous system, F is an ASBR. Correct. ASBR is a redistribution point. Right? So all the external router networks, see the network coming from other autonomous system. It may be another OSPF. It may be AGRP. Maybe ISIS protocol, whatever. If you are taking the routes from this and giving to this OSPF, we will call the networks of these as external. For this autonomous system, these networks are external. Likewise, for this autonomous system, this is external. Don't forget. External routes. I'm trying to introduce you some terminologies so that when we go further you will understand the concept very well without struggle. So we have learned that a router can run more than one OSPF. Are we running more than one OSPF here in ABR? No, it's one OSPF in 2 different areas. But what we just finished learning is 2 OSPF itself. One router running 2 OSPF. This belongs to one OSPF and this link belongs to another OSPF. That is what called as ASBR, autonomous system router. But if simply running 2 OSPF will not make it as ASBR. You need to redistribute the routes of this OSPF to that OSPF, that OSPF to this OSPF. Only then it can be called as ASBR. Now ASBR is the reason for an autonomous system to learn the networks of other autonomous system. Is it true or false? Yes, it is true. ASBR is the reason for an autonomous system to learn the networks of another autonomous system. Yes, no?
Yes, sir.
Thank you, sir. Let's go to the next one. We also learned OSPF sends hello packet every 10 seconds. Every 10 seconds, the hello packets are sent between the OSPF neighbor. If a neighbor stops sending hello for 40 seconds, the neighbor will be considered dead. So you can call 40 seconds as dead timer, 10 seconds as hello timer. You know, when someone says hello in the airport, you will say hello back depending on how they look, what they are up to, in what situation they say hello to you. A lot of things involved in it. If someone says hello, see I have too many luggage. If I check in, they will charge extra for excess baggage. Will you please share some load because you don't have much load? If you will share some load with me, I no need to pay the excess baggage fees. Will you agree? Don't agree, I advise you. I agreed for many times in the initial days. But nowadays days are crucial. If you take their luggage into your account because you don't have luggage, he or she will not be paying for the excess baggage, that is true. But what if the luggage that is shared with you has got some smuggling items? You will be in jail. He or she won't go to jail because it was under your ticket enrolled. The baggage is enrolled. So when someone says hello in airport, we need to take some backward step. Who is saying hello? What's the intention behind this hello? Then you can say hello back. I never say hello to anyone in airport because I don't know any one of them. I don't like to disturb others. Mostly it is like that. But sometime you will see in some countries many hellos will come to you. You need to be very careful about those countries. Very, very careful. So you check for parameters. Who is saying hello? How he is looking? Is he looking like a normal person? Is he looking like a good traveler? And then you can say hello back. Likewise, OSPF sends hello from every router via every link using a multicast address 224.0.0.5. When D sends a hello packet to this address, or let's say E is sending hello packet to this address, when it says hello, all can hear that. This address is not the address of B, A, C, D, but B, A, C, D can hear the hello sent to this address because they also run OSPF. Whoever runs OSPF can hear the voice of other OSPF because they all use one common frequency 224.0.0.5. When devil speaks, animals can hear, people used to say. But human being can't hear. Because devils and animals are in same frequency, according to them. Likewise, when one OSPF sends hello, only the other OSPF can listen. No others can listen. Can RIP router listen? No. Can EIGRP listen? No. Why? They all are in different frequency. What's the multicast status for EIGRP? Someone tell no? What happened? No one in the class knows the multicast status for EIGRP? Should we go back to the previous topic?
224.0.0.10.
10. Yes. For RIP it is 9.
9.
They all have got different address to speak. So when we learn multicasting as a separate topic, you will understand how multicasting makes this work. It's very interesting how multicast forms a group. So all the OSPF routers will form a group and they can listen to each other, others can't. So these hello packets are sent to this multicast address. When the hello packet comes, I listen and check for certain parameters. Is the hello coming from a neighbor who is in same area? Is hello coming from the neighbor whose network and my network is same? The subnet is same? Is the hello coming from a neighbor whose timer is same? If these things matches, only then I will accept him as my neighbor. So that is what here it is mentioned in the second line. Router declares the neighbor to be up after checking certain parameters like timers, area ID, network and subnet mask. And there are other more optional parameters also like stub. Here stub is in OSPF, not the EIGRP stub. Authentication type, authentication string, and so on. When these things matches, router will agree the neighbor as a neighbor. Alright, this is where from we need to start today. Let's now get into this understanding OSPF adjacency. I told you some time back, people will confuse you with two words, neighborship, adjacency. In English, neighbor is the one who is sitting next to you, who is adjacent to you. Both are same. But in OSPF, they give different meaning. Not everyone, some authors. But what I want to say is full adjacency is one type of neighborship. Two-way adjacency is another type of neighborship. Full neighborship, two-way neighborship. These are the two actual classifications. But for the two-way adjacency, they will call it as neighbor. Some people. Two-way adjacency. What is two-way adjacency? I'm going to explain you in some time. Two-way adjacency is not full adjacency, okay? Two-way adjacency, they call it as neighbor. Full adjacency, they call it as adjacent. If the neighbor house is saying hi, hi daily, then it is two-way adjacency. If the neighbor is not only saying hi, every time they make dosa they share with you. Every time they make biryani they share with you. Every time you make some pongal, you share with him. Then it is full adjacency. Both have become one thick friend, like both become one. It's not two family. That is full adjacency. Not even smell is coming through my window. That's the adjacency I have. Anyway, we have two type of adjacency. Full adjacency, two-way adjacency. Two-way adjacency is high. Whenever you see, he will say hi and you will also say hi. That's all. I don't know what he is doing, what business he does. He don't know what I am doing. Then it is two-way adjacency. But I know him. He is in my street. He is next to me. That is what we call as two-way adjacency. But in OSPF, some authors will call that as neighbor. But when idli, chutney, pongal is shared, they will call it as adjacent. When all the routes are synchronized fully, when the complete LSDB is shared with the neighbor, when that neighbor shares the complete LSDB with this neighbor, we call it as full adjacency. But they will call that as adjacency. Anyway, should not get confused with that. Forming adjacency is two-way adjacency or full adjacency. That's all you should think. There is no other classification. Neighbor, adjacent. No. They call two-way as neighbor. They call full adjacency as adjacent. That's not the right way. I'm trying to tell you, you may find some documents like that. You shouldn't get confused. Even in class, when I was teaching in different companies, they are already confused. So they will confuse us. They will not ask question. They will say as if they are talking from their own mind. That full adjacency, sorry, they will not say full. That neighborship and this is forming neighborship and that is forming adjacency. What, man? Both are same. If you say both are same, then they will quote one book and page number. It's very dangerous to talk to such people. They confuse all in the class. Not only they are confused, they will confuse all in the class. Especially in India, you can see a lot like that. Point-to-point WAN will form full adjacent. See with neighbor. Point-to-point WAN means what? Point-to-point WAN. This type of connection is what called as point-to-point WAN. This is a WAN link. Serial links are called as WAN link. And serial links are also called as point-to-point link. This cannot be a multi-point link. Point-to-point link. Serial link. Have you seen a switch with the serial ports? No. You will have only Ethernet ports. If you have Ethernet port, you can connect many routers and these routers form multi-point. But when you got only a serial port, you don't have a switch for serial port, you can connect to another router. That's all. So what is this? Point-to-point. So when you have a point-to-point WAN link between two routers that runs OSPF, point-to-point, this is how we draw. Zigzag. When you run OSPF between two routers that is connected via point-to-point, they will become full adjacent neighbor. What is it? Full adjacent neighbor? You know that. If you are not there, who is there for me? Only you can take care of me. and only I can take care of it. It's only we two. We only need to help each other. That is full adjacency. Idli, chutney, everything they will share every day. That's full adjacency. But on LAN link, it is not like that. On LAN link, this is what called as LAN link. You are connected via Ethernet. And you got an Ethernet switch. Even if you have two routers using Ethernet, fast Ethernet 00, fast Ethernet 01, something like that, even this is considered as LAN by OSPF. This is also LAN, this is also LAN. So what I'm going to say now is applicable for this as well as this. So what happens when you are having a LAN link? Neighbors are formed with full adjacency only with those routers that are elected as designated and backup designated. With all other routers, it maintains two-way state. With all other routers, it maintains two-way state. Who are all called as all other routers? Other than DR and BDR, all the routers, they're all actually called as DR other. All those routers, with all those routers, DR other routers, there will be only two-way state. Routers maintain two-way state with other routers, designated routers. Neighbors form full adjacency only with designated and backup designated router. Two-way relationship with designated other router. DR other router. So what we see here, in a LAN environment, there is a router going to be elected as a designated router. Another router as a backup designated router. The rest of the routers will be DR other. For example, between these two, if the router ID of this router is 11111, if the router ID of this is 2.2.2.2, this will say I am DR. And this will say, yeah, I agree. You are the DR. I'll be the BDR. And because there is only two routers, there is no other routers. There is no DR other role to anyone. Whereas in this topology, let's say this is 1.1.1.1, 2.2.2.2, this is 3.3.3.3. This router will say I am designated router. This will say I am backup designated router. And this will say I am designated router other. I am designated router other. Now, between the designated router other, let's say I got another designated router 4.4.4.4 R4. This is also designated other. Between these two routers, they will have only two-way state relationship. But with the designated router, they are going to have full adjacency. So, you see, whenever we got more than two routers in an Ethernet environment, there will be a designated router and a backup designated router election. Meaning, if you have a team of 15 members doing a project, if a project is given to the team, Definitely there should be one person elected as a servant. He is called as manager of the team. He is a servant. He should go and talk to everyone daily and take the status. How much you have finished, how much is left, when you will finish. He should have a good wrap up with everyone. Is there any difficulty you are facing? How may I help you to overcome the difficulty so that you will finish on time? That's the good quality of a manager. If he cannot be a good servant, he cannot be a good master. So, one person with that quality of serving others will be identified by the management, and he will be elected as the manager of the team. That is how it should go. Only then a project will be successful, but it is going opposite. That's why projects are not successful. So one person who is really down to earth, always ready to listen, ready to help others in their ignorance, not to boast. You don't know even this OSPF concept. Why you have come to this job? Who elected you? Or who conducted interview? These are all nonsense talk. That cannot be done by a good leader. In his ignorance, a leader should sit and teach him, okay, see, this is what you are going wrong. This is where you are going wrong. Actually, this should be done like this, according to my knowledge. If I am wrong, you correct me. That is good leader. So, when you have such leader, everyone will come and report to him very happily daily. He will, sir, I have finished this. I have finished this. Is this okay? And when the leader finds one employee is not really having that skill to finish it, he will try to cover it and give that portion of work to someone who can do it and make the project finished within that stipulated time, given time. Likewise, when you have many routers connected through a LAN, there will be one designated router, leader, a manager for the project is elected. What is the job of that DR, designated router? It is to talk to everyone, collect the information from one and give it to other without any duplication, and make everyone to sync without any duplication. If there is duplication, there will be loop to avoid duplication. See, if there is no manager for the team, what will happen? Loop will happen. One will think that he is also in the team, he is very good in C++, he will do this module. And what that person will think is, this fellow also studied MCA with me, he was very good in C++, he will do that. Let me not focus on that module. So no one is going to do the project. That's why we need one manager, one designated router, one servant who can talk to everyone, who can do some balance between everyone with everyone, who can move the project to next levels in spite of all their differences in skill set. Likewise, designated router here avoids loop. Designated router avoids duplication of update going to the members in that broadcast. Why I call it as broadcast? Because it is connected to one LAN in the middle. They are all in one broadcast domain. One LAN, that is what one broadcast. One LAN. To avoid duplication of update, to avoid loops, we will not talk to everyone. We will talk only to the designated router, the manager. And manager will talk to others. If I have a problem, I don't talk to everyone. That will cause loop. I talk to the manager, and manager will talk to the others about the problem. That solves the problem. Because everyone is ready to listen. So with the manager, everyone will have what? Full adjacency with the designated router, and there is an assistant manager, backup. We'll talk in detail later. Full adjacency will be only with the designated router, but between the other routers there will be only two-way relationship. Like I said, between this R1 and R4 two-way relationship, but with R4 and R2 there will be, or between R1 and R3 there will be full relationship, full adjacency. Routing updates and topology informations are passed only between the adjacent routers. Right? Only when we have full adjacency, the routing updates and topology informations are shared. Once an adjacency is formed, LSDBs are synchronized and exchanges LSA. So this is talking about the full adjacency. They synchronize by sharing their database. LSs are flooded reliably throughout the areas. See again, you can expect the topology to be identical only within the area. Why? Because the LSs are flooded only within the area. It will not be going to other areas. Flooding will not happen. That's another way how the advertisement goes to other area, which we will talk later. So here in this page, very important page, what we learn is between point to point there is no need for designated router and B. See, there is only two people in the team. Why I need a manager? If I want to know the updates on the project, I'll call those two people and ask what's the status of the project. Only when there is team of 15, I cannot call all 15 and ask, hey, what you have done, what he has done. No, I don't have at that time. We appoint one manager for the team who comes as a mediator between the team and the management, who makes the team to work without any conflicts between them. But some management people are making conflict between the employees now. They are working opposite of what they're supposed to do. I have a lot of students in our class, in various classes. They come and say, my senior is what the problem for me. That's why I'm leaving this job. That's not the way it should go actually. That happens more in our country. So to avoid conflicts, we will have a designated router and a backup designated router and the other team members. More about these things is what we are going to focus in our next class. But let's go to the next slide now. OSPF, how it calculates the best path. As we already spoke, the LSAs are flooded to everyone. They form LSDB. And on the LSDB, the SPF algorithm runs and picks the best path, calculates the best path, the path based on the bandwidth, and the path is put into the routing table, which is what we call it as forwarding database. But again, I want to remind you one thing. OSPF may give a best path, but routing table also have got some criteria, no? Routing table will not simply take and put whatever OSPF gives. Routing table will say, wait, who are you? OSPF. What is your administrative distance? 110, sir. Okay, wait. Who are you? I'm EIGRP. You're also giving the same network what OSPF is giving? Yes, sir. What's your administrative distance? 90, sir. Okay, EIGRP, welcome. OSPF, sorry, I cannot use yours because your administrative distance is more. That point I want to remind you. Best routes are going to be elected, no doubt. OSPF will elect it, but it is the decision of the routing table algorithm. That's the final authority, whether to put that route in the routing table or not. The best route will be recommended to the routing table by OSPF. OSPF will say, this is my best route. EIGRP will say, this is my best route. Both are in the same router. Administrative distance will also come into picture. If it is mentioned here, it would have been better. They didn't mention here. Sometimes people forget that particular part, administrative distance. Right. So if you see here this picture explains the SPF algorithm, how it finds the best path. For X to, this is the link state database on every router. For X to reach D, you can go via A. You can directly also go. Which is shortest? Going directly. That's why you got a through line. Elected path. The through lines are elected path. If each link is 10, this is 10 plus 10 is 20. But if you come via this way, it is only 10. The low cost path. The low cost path is what going to be given to the topology table. Now this is the last page and then we will finish today's class. You see, link state advertisement is coming. Or a link state update is coming. The update is for the request. If someone sends the LSR, then LSU will come. Anyway, that is also an advertisement. It is coming. When a router receives an advertisement, it will check whether it has got anything in the database. Is my database empty or it has got some information? I got some information. If I have some information, when the update is sent, it is sent with sequence number. Is the sequence number same what I have or different? If it is same, I'll just ignore the update because I am already updated. In case if my database is empty, I'll just update whatever I receive. Send an acknowledgement and flag the information that I learned to the other routers downstream. And then I run SPF, find the best path for myself. Here we saw if the database is already there with some info, I'll check the sequence number. If the sequence number is same, I ignore. If the sequence number is not same, I'll check whether it is bigger or lower. If it is bigger, if the incoming sequence number is bigger, which means I need to update, I go and add it to my database. If it is not higher, which means the incoming is lower, which means I am already updated, the sender is not updated, so I'll send my LSDB to the sender saying, sender, you are outdated. First you update yourself. Take this. So this is how, with the help of sequence number, OSPF routers will know that they are fully updated or not. So every time there is a change happens, the sequence number gets incremented. About the sequence number also in detail we'll be seeing in our next class. Right. So we'll do this page one more time. From this page we'll start again one more time in our next class. Hope you enjoyed today's class. Do you have any question? Please ask.